Okay, so let's look at some examples that are concrete and will help us think about inertia. Again, as a reminder, we're focusing on uh, either the horizontal or the vertical. We can't look at them at the same time. So in this problem, we're going to look at the horizontal direction. Horizontally, we don't see only one force. So the question, are the forces balanced or unbalanced? They're unbalanced, meaning there is a net force of, in this case, 50 newtons horizontally. Now, we notice that the object is initially moving to the right, and the unbalanced force is to the right. So this force is going to create an acceleration that reinforces the existing velocity. So it's moving to the right, it's accelerating to the right, so it's going to speed up, getting more and more, getting faster and faster. All right, in this example, still looking at the horizontal, looking at the horizontal direction here, we're initially moving to the left. When you look at the horizontal forces, 10 to the left, 10 to the right, nobody wins this tug of war. So that means the forces are balanced. And because the forces are balanced, there's no acceleration. So the object that was moving to the left is going to continue to move to the left, and this is important, at a constant velocity. Next, we look at this example, again, the horizontal direction. If you look horizontally, you see 30 to the left, 10 to the right. That means that there's an overall force, net force, to the left. These forces are unbalanced horizontally. So if it was moving to the right, but the unbalanced force is to the left, that means it's moving to the right, but the acceleration is to the left. It's going to slow down. And if the forces were unbalanced for long enough, the object would eventually stop and then change directions. But we don't have to worry about that for now. All right, so we look at this one right here, and you see that now we're looking at forces in the vertical direction. We see that there's a total of 18 newtons up, 6 newtons down. So if this were a tug of war, up would win the tug of war. These are unbalanced. Now, because it was initially moving down, but the acceleration is going to be up, that acceleration opposes motion, so it's actually going to slow down.